Okay, so now let's talk about floods. So flooding and sedimentary load is strongly related to each other, and we'll talk about sedimentary load in more detail later on. One thing that I would like to mention in this slide is that most erosions and sediment transport occurs during flooding, and as you can see here, this river right here is transporting lots of suspended load. And here is the picture of the Yellow River in China that carries a tremendous amount of suspended load, such as silt, that takes up to 70% of the river's volume. And the moving water that we have in rivers actually can cause erosion in several ways, including the first one here, scouring or the removing of loose fragments. And second one here is breaking or lifting. Basically, it's a snapping off fragments or lifting the fragments off the riverbed. Um, Erosion can also occur through abrasions or grinding action of the sand in the water column, as well as dissolution by dissolving more soluble minerals that we have in riverbeds, for example. And the severity of erosion depends on several factors, including the water velocity, the water volume, as well as the sediment content within the water column. And there are three types of sedimentary loads that I mentioned earlier. The first one is dissolved load, second one is suspended load, and the third one is the bed load. Dissolved load represents the finest particle that we have in the water column, and they represent ions that have been dissolved in the water, such as sodium ions or chlorine ions, calcium carbonate, and sulfate, and many more. The second one is the suspended load, representing the clay to silt sized particles. And remember, these are the fine particles, fine sedimentary particles that have been floating in suspension within the river, within the water column. And most of the sediment carried by a stream is suspended load. And the last one is called bed load, and they represent sand particles, pebble, and cobble sized particles. Basically, these are coarser particles that we see in the water column that have been pushed or rolled along stream bed. Basically, these larger particles, when they travel down the stream, they constantly touches the riverbed, and they can touches and they can move with rolling action or saltation. Sometimes they jump and jump and jump. Here's an example of a great floods of April 2005 that occurred in Pennsylvania. As you can see here, this is the Delaware River. Um, and you can see the water looks very murky because of the high level of suspended load within the water column during the flooding. And here is the floods that occurred in New Brunswick and Piscataway area during a storm several years ago. As you can see here, this is the water that is coming from the Raritan River. If you have not noticed yet, this is Rutgers Stadium right here. So this is Bush Campus right here. As you can see here, this water looks very murky again because of the amount of suspended load within the water column. Floods occur when volume of river water is so great that the water rises and overtops rivers' natural banks or levees or artificial banks as well. Sometimes in some areas people build artificial banks, but floods occur when basically when the water rises, over these either natural or artificial banks. So I mentioned about levees in the previous slide. So what are they? They are basically the boundary between the channel and floodplain, and they consist of sediment built along the side of the channel. So for example, here is my meandering river right here. So this looks like a meander river. And here on the side, on the shoulder of that channel, I have a build-up sediments right there. And that is what we call as levees. Okay. Now levees can actually, protect the flat lying areas behind it from floods. But of course, if the water rises too high, then it's just going to overcome the level of the levees, and floods would occur. So levees occur because of floods. Levees form when sediment-laden flat water overflows the channel and slows as it moves onto the flat plains. And because of the slow-moving water that we have here on the flat plains, therefore it actually allows the deposition of sediments right here, right on the shoulder of that main channel. Okay, and that's how natural levees form through several episodes of floods. Floodplains and levees, humans like to, as I mentioned in the first video of this topic, that humans love to occupy the floodplains because these are flat lying areas. It's just a lot easier to build within a flat regions. So we choose to live in flat plains and modify this feature. And artificial levees provide a false sense of security, leading to development of floodplains. And this could be, this could lead into disasters basically, because levees, especially natural levees, can fail. As you can see here in this picture, this is a failed levee in the Mississippi River that occurred in August 1993. 700 section of levee failed because of the water stage had overcome it, and the toe undercutting that happens right below the levee and the rapid drawdown were the major factors of the failure of this levee. Okay, so natural levees can fail, and again, it can lead to a false sense of security to live right behind the natural levee. So we really need to be paying attention to that. So again, overtopping of the banks by water, that's something that we call as the flood stage. Okay, and there is also another term called flood crest. Flood crest represents the highest level above flood stage river reaches during flood. So for example, this is an illustration of what we call as the hydrograph superimposed on hypothetical stream valley. So the hydrograph is represented by this blue line right here that you see here. So usually we start from the left, and this is the normal day of the river level, of the level of the water in the river. And then once we have a high amount of water coming into the channel, then it will start to increase and then reaches the bank full stage right here. This is not flood stage yet, and right here, this point right here, when it actually goes above the levee or the natural bank's elevation, that's when we start to call it as flooding. Okay, and here, everything here, this is the flooding event, and this will be the flood crest. This is the highest level that the water reaches during flooding, and then from this point on, it will fall again into normally into the normal level right here down below. Okay, so everything here that you see within this line right here, okay, these is represents the time, the duration of flooding event. Floods can occur because of these factors that I have listed here. Typically, it's a combination between at least two of them, two factors, or sometimes you can have a combination between all the factors that you see here. So flooding is a function of the total amount of distribution of precipitation, basically the amount of rain or snow that we had in that region. The second one is the rate of infiltration and runoff, meaning how much water that got into the ground and become part of the groundwater, and how much water that goes on the surface of the earth. And the last one is the topography also plays such an important role, and we'll see that in the next few slides. So, for example, for high precipitation, this is the first factor. In 1993, we had a really good study case in Great Midwest Flood. This is the junction of Mississippi, Missouri, and Illinois River right here. All right, so we have Illinois River right here. We have the Mississippi River right here. We have the Missouri River right there. Now, what happened here is that we have three major rivers coming here into this location. And then in 1993, for some reasons, the 1993 regional weather patterns created this rain machine. Right? At that time, they called it as a rain machine over upper Midwest that led to the great 1993 Mississippi and Missouri River floods. Okay, so here is we have the cool, dry air right here. This is the approximate position of the jet stream right here. So we have the convergence zone right here where we have the rain machine. So there's lots of excuse me, there are lots of rain going on here because we have the cool dry air right there and we have the warm moist air right there. So basically the weather pattern at that time creates a very nice, basically brewing, it was brewing a big major rain machine as they called it. So what happened there is because of high precipitation, the 1993 Great Midwest Flood occurred, especially near the junction of those three major rivers. As you can see here, the effect was very devastating. All right, this is actually natural levees got breached by the flood as well. All right, so the high precipitation, again, the 1993 Great Midwest Flood actually caused a township of 900 people moved to high bluffs, and the mayor at the time introduces new community plan. So basically, they understood that they live in a big floodplains, and a major floods like this will eventually occur again in the future. So they actually made a very dramatic decision to actually move the entire town to a new place in higher elevations. So again, this is what happened here in Illinois. Summer 1993, Mississippi River flood submerged many towns, including the Valmeyer. So they basically moved the entire city or town of Valmeyer to a new place. All right, another study case that I would like to mention here is the flat topography. Right, remember that the topography is one of the main factors that could affect, that could influence flooding to occur. All right, so here in the Red River flood, the youthfulness, the flatness, and slope direction of the Red River Valley all contribute to the susceptibility of flooding. Okay, and the Red River flows northward. So typically, for example, Mississippi River, we know that the Mississippi River flows southward all the way into the Gulf of Mexico in the south, right? But the Red River is actually a little bit unique because it actually flows northward. So the downstream part of it, it's actually in the Great Lake in the north. Okay, so the Red River flows northward. At the same time, it happened during the spring. So the spring thaw proceeds steadily northward along the valley, right? So in the southern part of the river, we have the spring happens, and so the snow started to melt at the time. But remember that as we go to the northern part of it, the weather is still a bit cold in the north, right? So during floods, Red River at Drayton tends to pool due to lack of slope because the flat topography that we had in that region. So essentially, the region become a massive shallow lake, as you can see here in this picture right here. Okay. As you can see here, the weather was still a bit cold because in some parts of the flood right here, the water got frozen actually. All right. And then what made it worse is that the Red River got plugged. That system got plugged because the river flows northward into colder climates, and the ice from the south progressively meets with the freshly broken ice in the north. So therefore, at the time, we had ice jams that occurred, basically retarding or damming the water flow in the Red River, and it made it even worse. Okay. So those are several things related to floods, some basic concept about floods, and some study cases of major floods that have occurred here in the United States. And I'll see you again in the next video.